Math 1, Practice 2.5.1 and 2.5.2. So getting some extra practice in class. If you didn't finish this in class or weren't here, then this is what you need to do. So these first ones we're just dealing with graphing linear functions, and then we'll do some exponential. So, number 1, given the function f of x equals negative 2/3 x minus 4, use the slope and the y-intercept to graph the function. Identify the x and y-intercepts. So, draw a graph here. So remember, the y-intercept we can see as the number that doesn't have the x with it. So the negative 4. So we'd go down to negative 4 on the y-axis, draw our point. That's our y-intercept, right? 0, negative 4. Then we would use the slope, the number with x, the rate of change. So it's negative 2 over 3. So we'd go down 2 to the right 3. Now you should be able to see that that's getting us further away from that x-axis. So you can also go backwards. We can go up 2 to the left 3. Put us right there. Up 2 more, which would put us on the x-axis, to the left 3. And there would be our line. We'd graph it. That would be at negative 6, 0. And that would be our x and our y-intercept, where it crosses the x-axis and it crosses the y-axis. Now, number 2, given the function f of x equals negative 3x plus 9, once again use the same thing. So it's the same idea. We go up to 9. Okay. Remember, with linear, that's our y-intercept. So y-intercept is 0, 9, because y-intercepts always have zeros for x. Okay, then the x-intercept, we use that slope, negative 3. So the slope is negative 3 over 1, so down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1, and that puts us on the x-axis, where x equals 3, so the x-intercept is 3, 0. Remember, the x-intercept always has the y value as 0. Okay, which on the next one it says, given the table of values, graph the function and identify the x and y-intercepts. Okay, so remember, with the table we can just graph the points. So negative 7, negative 6. That would be that point. Okay, negative 5, 0. Notice the f of x or y value is 0, which tells us that should be our x-intercept. So negative 5, 0 would be right there. That negative 5, 0 is our x-intercept. Okay, negative 3, 6 be right here. Oh, negative 3, 6 right there. And then 0, 15, that's going to be our y-intercept, because it has the x value of 0. So I'd go up to right about there and try to draw my graph. Obviously my hand-drawn coordinates are not the best, but it looks something like that. Okay, number 4, same idea. Given the table of values, graph the function, identify the x and y-intercepts. Okay, there's our y-intercept, there's our x-intercept. How do I know? X has a 0, so it would be our y-intercept. Honestly, on a graph, I could just graph those 2 points, and that would be good enough to draw my graph. So that's our y-intercept. Then 2, 0 would be our x-intercept right there. Could I graph the other 2 points? Yeah, but 2 points is enough in a linear function to graph it. Now, 5 and 6, it wants us to actually solve for the x and y-intercepts and then use that to graph. So instead of just using this y-intercept and this slope, they want us to think of it like this table, and realizing that if f of x is 0, that gives us our x-intercept. If x is 0, that gives us our y-intercept. And so they want us to do that in order to solve. So the way we do that is we take our function for the x-intercept. Okay, f of x has to be equal to 0. So instead of f of x, I would go 0 equals 7/3 x plus 7, and then I would solve for x. So I'd subtract 7, get negative 7 equals 7/3 x, times by 3, because we've got 7 divided by 3, so times by 3 gets rid of the 3 on the bottom. And then I've got 7 times x, so I divide by 7. So I end up with negative 3 equals x. So if I were to make a table, that x would be negative 3, where f of x, or y, equals 0. Okay? On a graph, I go back to negative 3. Okay? Then I do it with x being 0. This one's usually the easier one to deal with, because all we have to do is evaluate our function. So I want to find f of 0. So I go 7/3, put in 0 plus 7. And because we know this is the y-intercept, it makes sense that that cancels out. We've got f of 0 equals 7. So our y is 7. And then you draw your graph. And that's all there is to it. Okay, so number 6, same idea. So first off, I make f of x 0 and solve for x. That's for my x-intercept. For my y-intercept, I go f of 0, or in other words, make the y 0, or the x 0, whereas before I made the y. So f of 0, pretty plain to see, equals negative 16, because negative 8 times 0 is 0. 0 minus 16 is negative 16. And for the other one, we would add 16. 16 equals negative 8x, divide by negative 8, and we get negative 2 for our x-intercept. So if we made a table, it would be 0, negative 16, and negative 2, 0. For our y-intercept, negative 16 right there, x-intercept, negative 2, and there's our graph. Now remember, if you have Desmos on your phone or go online, that's a great place to graph all these, to check your work, to see how well you're doing. You can even make a table on it. Or, if you have a graphing calculator, you can use that as well to help you double check those things. Alright, now we're going to make some story problems. Now with these story problems, the best thing to think about in these situations is we're not going to use that same format. We're going to use a different equation. It's called standard form equation. Now, the a is usually a number, b is a number, and c is a number. So we still have the x and the y, but because of the situation, usually it makes sense in a lot of story problems to use this format. And then this format goes along really well with your x and your y-intercepts, because if I make y 0, b times 0 gets rid of that, so it's just ax equals c, which is easy to solve for x. And then if I'm doing it the other way around to find that would find the x-intercept. To find the y-intercept, I'd go a times 0, which that eliminates that, so it's just by equals c, which then you divide by b, and so you can find the y-intercept. So that's the usefulness of those, the standard form equation, which goes along with this stuff that we're talking about. So anyway, Chris is collecting cans and bottles to raise money for his baseball team. He gets $6 for each bag of bottles collected and $5 for each bag of cans collected. Okay, so bottles we could call Y, cans we could call X. Okay, so he earns 6 per bottle, so if we take 6 and multiply it by how many bottles he has, and then 5 for each can, okay, 5 times X, Chris needs to collect $30, so he wants $30. Okay, write a function to see how much he needs to collect. Well, if we added how many bottles and cans he collected and spent, and set that equal to 30, that would tell us what we need to do. So then, it says if he collects only bottles. Okay, that's like just finding the Y, getting rid of the X. That's the same way as what I was talking about. That would give us our y-intercept. So we'd go 5 times 0 because he found no cans. And then 6y plus that, 5 times 0 is 0. 6y equals 30. Divide by 6. And we get y equals 5. So if all he did was collect bottles, he would need to collect 5 bottles. Okay? Then we do the same thing for how many cans. Okay? So we'd make 6 times 0, which that would eliminate. So we get 5x equals 30, divide by 5, and we get x equals 6. So there's our x-intercept. So now if we were to graph that, let's draw a graph right here, y goes up to 5, x goes out to positive 6. There's our function, and we graph it. And that represents every combination of cans and bottles to reach $30. Okay? So, 8. Ashlyn makes leather handbags and belts to sell online. The belts require 50 inches of leather, so X can be the belts. And handbags require 350 square inches of leather, so Y will be handbags. I'll go HB. She has 700 square inches of leather, so once again write the function. Well, we take how many belts she made, times it by 50, add to that how many handbags she made, times that by 350, and that would be equal to 700. Then once again, what if we only make belts? What if she only makes handbags? So belts, we'd get rid of the 350y, because we'd say there's 0 of those. So 50 times x plus 0 would do nothing, right? So we just end up equals 700. Divide by 50. X would equal 70 divided by 5 is 12. I should know this, shouldn't I? 14. There we go. So she could make 14 belts. Now, what if we made it just the handbags? So we got rid of these by timesing that by 0. Well, 350 into 700 would only give us 2. So, there we go. Then we graph that. That goes to 2. This goes up to 14. And there's my graph. Okay? Now the last one, you should hopefully see that pattern we're using. Farmer grows corn and wheat. Let's call X corn. Y will be wheat. Each acre of wheat takes 120 hours to plant, so 120 for wheat. Each acre of corn takes 40 hours, so 40 times X. Okay, he has 360 hours to plant crops. There's our function. Okay, then to graph it, let's find out for only corn. So find out our X-intercept. So 40x would equal 360, because we times this one by 0, and it would eliminate. Divide by 40, and we get x equals 9. He could do 9 acres. That's our X-intercept at 9, 0. Okay, then for y, we'd make the x 0, and that would eliminate, so we're left with 120y equals 360. Divide by 120, and we'd get y equals 3. So we can do 3 acres of the wheat. So there's our Y-intercept 0, 3. And we graph the points. And there's our linear. Okay, number 10 then says graph of a function is shown. Write a scenario that could be represented by the graph. So find your Y-intercepts. Okay, one right there at 9. So 0, 9. Find your X-intercept. 3, 0. Okay, so you'll have x equals 3. Y equals 9. You'd want to go back up till you got something x equals something y or plus something y equals that. So think about it. X has to come down to 3 and y has to come down to 9. 3 can go into 9, right? So what's something that 9 could go into? Maybe 18. So in order for y to equal 9, you'd have to have 2y, right? Because 9 times 2 is 18, and 3 is times 6, so you'd have 6x. Okay, so you could maybe say something like, it takes you 6 hours to, I don't know, cut your fingernails, and 2 hours to cut your toenails, and you only have 18 hours to cut your, how many times could you cut your fingernails or toenails, something weird like that. But the idea is that basically that this is always going to have to be 3 times bigger than this. But they have to come up so that they end up equaling those X and Y intercepts. So you kind of have to work backwards on that one. Alright, now we're going to start the 2.5.2. So now we're dealing with exponential function. So now with these exponentials, it wants us to identify the Y-intercept and describe the end behavior. Remember, describing the end behavior is basically telling us where that asymptote is, right? That invisible horizontal line where the graph is getting close to. Okay. Now, remember with this format, this number in front is usually the y-intercept. The number added or subtracted is usually the asymptote. The thing is, the asymptote affects where the y-intercept is. So, like a y-intercept of -5 would normally be down here. Okay. The problem is that +3 is going to move the asymptote from the x-axis up 3, so it'll bump that up 3. So you basically take the first and that last and you add them together to get your y-intercept. So your y-intercept would be 0, -2, and then your asymptote would be y equals 3. And if you were to graph that, because it's a negative, okay, this, draw that 1, 2, 3, that asymptote would be at 3, we'd go down to -2, and our graph would look like that. Okay. If you need to use that graphing technology or Desmos to help you with that. Okay. Number 2, 3, 4, and 5, basically the same idea here going on. Okay. So I'd go 2 plus 20. So I have a asymptote as y equals 20. And then I have a y-intercept at 0, 22. If I were to draw the graph, I'd go clear up to 20, 22, and then it's got a fraction, so it'd actually be going down like this. Okay, at 3, we've got a +2 and a 4, so y-intercept would be 0, 6. Asymptote, or in behavior, would be +2, so we'd go up to +2 here, and up to 6, and then draw my graph. Because it's got a 6 for growth, it's going to be going up pretty quick. Okay, number 4 has a fraction like 2, so it'll end up being a decay function like that. There's no plus or minus, so our asymptote is y equals 0, the x-axis. Our y-intercept would then be 0, 4. So on a graph, it would look like 1, 2, 3, 4. It would look like this, going down. Okay. 5, same idea. A -5 for our asymptote. Our y-intercept, -2 plus -5 would be -7. So 0, -7 is our y-intercept. Graphing it. That would be our asymptote. This would be our y-intercept. So it would be going down like this. Okay, 10. Or 6, we've got 10 minus 8, so 0, 2 would be our y-intercept. Asymptote of y equals -8. So we'd go down one more for our asymptote. Then up here at 2 would be our y-intercept, so it would go out right this. Okay? And that's all we have to do for those ones. Now, 7 and 8. A certain radioactive isotope has a half-life of 8 hours. So every 8 hours, we're dividing by 2 or times them by a half. The starting amount is 55 grams. That's our y-intercept. Write an exponential function to model this scenario. So we'd go f of x equals our starting number, 55, timesing by 1/2, raised, now it's every 8 hours, so raised to x over 8. If it was every hour, it would just be x. But when we have a certain amount of time, you divide by that. Now, it wants us to find it for 24 hours. Okay, so there's a few different ways we can think through this one. You could make a table and think, well, this would be my first 8 hours, my second 8 hours, so 24 hours would be 3 sets. And then we'd start at 55, and then we'd divide by 2 each time, which we'd get 27.5, then 13.75, then 6.875. The other way would be to take our equation and replace that x with 24. Now hopefully you notice 24 divided by 8 is 3, which makes sense with that now, right? So we'd go 55 times 1/2 to the third. And we end up with f of 24 equals 6.875, which is basically what we said here. Okay, basically the same thing. So 8, same idea. You are growing bacteria for a science experiment. The number of organisms quadruples, so timesing by 4, every 13 hours. So it's going to be 4 to the x over 13. You begin the experiment with 10 organisms, so we begin with 10. Write an exponential function to model this scenario. How many organisms will you have after 26 hours? So they want us to say, okay, replace the x with 26. Replace the x with 26. 26 divided by 13 is 2, so simplify that. And then we go 4 squared, which is 16, 4 times 4. Then 10 times 16 is 160. So in 26 hours, you will have 160 organisms. Okay? Alright. Number 9. Connor invests $250 in an account that earns 3.7 interest per year. Write an exponential function to represent this scenario. How much money is in the account after 3 years? So they start, so f of x equals 250. Then what are we multiplying by? Not by 3.7. Remember, with investments, you take 100% and you add the interest onto it. So it would be 103.7%, or 1.037 to the x. Then we replace that x, right, with a 3 to solve, and we figure out in 3 years how much we have. So use a calculator. 250 times 1.037 to the third gives us 278.79 when we round, because it's money. And there we go. After 3 years, that's how much you have. Now on this one, writing a scenario, first thing to note is your y-intercept right here at 55. Okay, that's where you're going to start. And then it's going down, so you're going to somehow lose something. Okay, but it's never going to get less than 5. And it looks like it's going from 55 to close to 5 pretty quick, isn't it? So, but that jumps to 5. So within 5 years, you're pretty much down to 5. So I'll let you guys be creative on that. Think of a scenario. You start at 55 and you're losing something, and within 5 days, 5 weeks, 5 years, you're pretty much down to only 5 of them. Okay? And it does it pretty quick. Alright, there you guys go.